Let's briefly talk about the life cycle of stars. So, stars initially form from an interstellar cloud of dust and gas containing hydrogen, and this is what we call a nebula. Now, later on, gravity collapses all the dust and gas into a protostar. This protostar will then undergo a series of nuclear reactions, which will then result in an increase in energy production and increasing temperature. Now, as a result of this high temperature and energy, a stable star will form. But why do we call it a stable star? We call it a stable star because the inward gravitational attraction is equal to the outward gas pressure in the stable star. But this stability phenomenon is actually rapidly increasing the temperature of the stable star by nuclear fusion reactions rapidly occurring inside the star. So now, due to the immense amount of fusion reactions occurring, eventually at one point the fuel for these reactions, which is hydrogen, will run out. Once the fuel for this reactions, nuclear fusion reactions, have run out and there is not enough hydrogen, either two things can happen. If the solar mass of the star is 8 times less than the solar mass, scenario 1 will happen. If the solar mass is 8 times greater than the solar mass, another scenario will happen. Now, if the solar mass is 8 times less than the solar mass, then it will expand to form a red giant. Now, in the red giant, the balance of forces has been lost. So what's going to happen over time, the red giant is going to contract under gravity because there is no more balance of forces, and it will form a planetary nebula with a white dwarf at its center, okay? We call it white dwarf because it emits light, but over its few billion years, the white dwarf will eventually become a black dwarf, and it will be as if it is not visible anymore from our solar system because it will not emit any more light. Now, in the other case, if it is 8 times greater than the solar mass, it will continue to undergo nuclear fusion reactions and eventually form a red supergiant. Now, in a red supergiant, it's not like the red giant, okay? In a red supergiant, the outward force of gas pressure is actually greater. It outweighs the inward gravitational attraction. So because the outward force of gas pressure is greater than the inward force, it is going to explode in a supernova. Now, this supernova explosion is going to create a nebula, and this nebula will then contain hydrogen, some new heavier elements. It may contain or create new stars with new orbiting planets, okay? But the product it will leave behind can either be a neutron star or a black hole.